So we're going to start with optimization work problems. So to optimize a situation is to realize the best possible outcome subject to a set of restrictions. Because of these restrictions, the domain of the function is usually restricted. If the situation can be modeled as a function, it may involve finding either a maximum or minimum value of the function over a set of values, which is the domain. So for example, when we used to have quadratic functions back in grade 12 and grade 11, we would always try to find the point in which x would yield the greatest or least result. So the algorithm, or the steps for solving optimization problems, is step 1. We want to understand the problem. We want to identify quantities that can vary. We want to draw and label a diagram, if possible, and state the given or required quantities. So basically, write down what you know first. Number 2, we want to determine a function that represents the quantity to be optimized. Then, using the given information, write this quantity in terms of one independent variable. So if we have two variables, isolate for one variable so that you're able to substitute it in to another algebraic equation. And step 3, determine the domain of a function to be optimized using the given information. The domain must be written in terms of the independent variable used in our step number 2. And we want to use the algorithm for extreme values to find the absolute max or min on the function on the domain found in step 3. And last but not least, we want to use the results in step 4 to answer the original problem. We want to check our answer for validity. Does it make sense? And we want to indicate the correct units. So when we evaluate or find an answer, I want you to leave it in exact form. So you're either going to leave it in a root that is rationalized, if there is a root, or just leave it as an exact form. So if it's 45 pi meters per second squared, you leave it as 45 pi. You don't have to expand it and make it a decimal. So we're going to move on to some examples. So we have our first example over here. So we have a property owner has 600 meters of fence. She wants to enclose a rectangular field with one side along a wall. Find the dimensions of the rectangular field of a maximum area. So we have the wall on one side. That's what we're going to draw first. So we have my wall over here, because it's part of my rectangular diagram. Now, I have my rectangular field right here that's attached to the wall. So I have my length here, and I have my width over here. So what information are we given to solve this equation right away? What can we use? So we know our perimeter is 600. Perfect. So what would an expression for our perimeter be using the given variables that we have? $600 is equal to 2W plus L. Perfect. Now let's isolate for L because it's by itself. So we have L is equal to 600 minus 2W. So we have our length in terms of our perimeter and our width. And now we can go on to step 2. So we have determine a function that represents the quantity to be optimized. Then using the given information, write this quantity in terms of one independent variable. So what is the question asking us to do? what is the question asking us to do? Okay, so what is our formula for area then? What is the area of a rectangle? So you have area is equal to length times the width. So we know from our simplified expression in perimeter, we know that the length is equal to 600 minus 2w. So I can write 600 minus 2w times w, and then I can expand that. So my area is going to be 600w minus 2w squared. So all we're doing is using the information that we're given and coming up with a quadratic function for our area of the rectangle. So we know based off our area is equal to length times width. We know my length is equal to 600 minus 2w, and my w is just equal to w. Right, my width is just equal to itself. So we need to determine the domain of the function to be optimized using the given problem. The domain must be written in terms of the independent variable used in step 2. So for any measurements, can we have a negative value for our dimensions? No. Which means that my width has to be greater than or equal to 0, which is true. And my length also has to be greater than or equal to 0. But because my length is equal to 600 minus 2w, we can write it as an inequality. Is greater than or equal to 0. I can move my 2w over. Becomes greater than or equal to 2w. Divide both sides by 2. And I get w is less than or equal to 300. So my domain, so my dimensions, so my width has to be in between 300 and 0. So w is less than or equal to 300, but also greater than or equal to 0. So when it comes to optimization in calculus, we always take our derivative to help us figure out what my maximum or minimum is going to be. So we have our area in terms of w is equal to 600w minus w squared. So now to optimize this to help us find what our w is going to give us, we have to take the derivative. So if I take the derivative of a of w, what am I left with? What would my derivative be? So I got 600 minus w, 2w. Perfect. So now all I have to do is set a prime of w equal to 0, because that's going to give us our maximum when a prime w is equal to 0. Oh, 2w squared. Yep. Whoops. My bad. Thank you for catching my mistake. So it's 600W minus 2W squared, and the derivative would be 600 minus 4W. So now we set A prime of W equal to 0 because that's when it will give us its max. I'm going to isolate for my variable, so I'm going to move my 4W over to the other side, and then divide both sides by 4, which means my W is equal to 150. So does W equal to 150 work in this case? Does it fall within my domain? Yeah. So this falls within my domain. So now I have to evaluate my area at the certain W value. So I know my area at 150 is equal to 45,000 meters squared. If I take my area at 0, I get 0 meters squared, and my area at 300 is equal to 0 meters squared. So the reason why I got 300, why I'm evaluating at 0 and 300, is because my expression was A is equal to 600 minus 2W times W. So my roots are W is equal to 30 for 300, and W is equal to 0. So now with this information, I can therefore find my dimensions. So I know my width is going to be 150 meters. But now I have to find my length, which is expressed as 600 minus 2W. So I take 600 minus 2 times 150, which gives me 600 minus 300, which gives me my length of 300 meters. Which means, therefore, my dimensions have to be 150 meters by 300 meters to produce a max area. Is there any questions about this as of right now? Any questions? If so, what are the questions? Yeah, it says max area, sorry. So my dimensions have to be 150 by 300 to produce a max area. So why would we have to set my A prime of W equal to 0 in order to find my max area? Can anyone tell me why? So why do I have to set this guy over here equal to 0? So when I set my derivative equal to 0, I'm basically calculating where my graph has a slope of 0. So where is it not moving? And that usually happens at a maximum or a minimum. So yeah, thank you, Priyanshu. That's exactly what I was just explaining. So by setting the derivative equal to 0, means that the slope of my tangent is equal to 0, which means that my function is at a maximum or a minimum. All right. So I'm going to move on to the next one. Again, more optimization questions. So a box with no lid is constructed from a piece of cardboard that measures 16 centimeters by 30 centimeters. So you got 16 centimeters and 30 centimeters. Congruent squares are cut from the corners of the cardboard and the resulting sides are bent upwards to form a box. So you guys probably remember these types of questions. What size should the squares be in order to obtain a maximum value? So when it comes to these tiny squares, because they're a square, what should each side be labeled with? So because it's a square, the length is x and the width is also x. So what would my length and width be if I cut squares on either side of the box? So what would my new length be? Because remember, I have to fold this up, which means my length is going to shrink. So what would be my new, thank you, 30 minus 2x? And what would my width be? So what would my width be? 16 minus 2x, perfect. So what formula do I have to use in order to find the size of the squares to produce a maximum volume? So what formula am I going to have to use? Anybody? So we're going to use volume, thank you, Priyanshu, is equal to length times width times height. So my length is going to be 30 minus 2x times 16 minus 2x multiplied by x, because that's going to be my height. So when I expand all of this, I get 480 minus 32x plus 4x squared minus 60x, all multiplied by x. And then I get 480x minus 92 x squared plus 4x cubed. So now my next step, using the factors that I have, I need to find my domain. So remember, we have to find my length, width, and height in terms of an inequality. So my length has to be greater than or equal to 0. Same with my width, has to be greater than or equal to 0. And same with my height, has to be greater than or equal to 0. So I want you guys to come up with my domain for this equation. Let's see what you guys come up with. I'll give you 3 to 5 minutes to figure out what my domain should be. Yeah, so L, W, and H all have to be greater than or equal to 0 because I can't have any negative dimensions. So remember, L is represented by 30 minus 2x, so put that as a inequality. My W is represented by 16 minus 2x, and my H is represented by x. Okay, Priyanshu, you got x is greater than or equal to 15 and less than or equal to 8. Does everybody agree with that? Are you guys sure? If I sub in 15 for x and 16 minus 2x, what happens? So my length is 30 minus 2x, greater than or equal to 0. So I got 30 is greater than or equal to 2x. I got 15 is greater than or equal to x, which means x is less than or equal to 15. Am I able to use this? Yes or no? And then we'll look at my width, so then you guys see what I mean. So what happens when I have x's between 15 and 8? What does my width become? Positive or negative? If I sub in 15 for 16 minus 2x, what do I get? A positive or a negative measurement? A negative. So I cannot use x is less than or equal to 15 because my width is going to produce a negative number. And then for h, I just get x is greater than or equal to 0. But Priyanshu does have a point. Our height has to be only bigger than 0 because if our height is 0, then we just left with a 2D shape. So my domain is going to be x is less than or equal to 8, but greater than 0. So now what I need to do is to find my max volume. So volume max in terms of x. I need to find the derivative of my volume function. So what is the derivative of v of x? Who can tell me what the derivative of v of x is? So 40 minus 184x plus 12x squared. Perfect. So let me arrange it in order from degree of least to greatest to least. So I get 12x squared minus 184x plus 480. So what number can I factor from 12x squared minus 184x plus 480? What can I factor out? Okay, I'm going to factor out a 4, but I have to set my derivative equal to 0 to find out my max. So I get 4 bracket 3x squared minus 46x plus 120. So now I need to factor out my trinomial. If you guys can factor out 3x squared minus 4x plus 120, what two factors do I get in the bracket, or what brackets do I get? So factor out the trinomial for me, and then type your answer in the chat. Now you got 3x minus 10 and x minus 12. Does everybody agree? So what are my two possible x values at which my max can occur? So what are my two x values that my max can occur at? So you got x is equal to 10 over 3, and x is equal to 12. So do both of them fall in my domain? No. So x is equal to 12 is not in my domain, which means that my only possible x value that gives me a max is when x is equal to 10 over 3. So when I plug in volume at 10 over 3, I get a volume of 725.9 centimeters cubed. At v is equal to 8 or 0, I get 0 centimeters cubed. And at v is equal to 8, I get 0 centimeters cubed, which means that my maximum happens at 10 over 3, which means that my squares, so therefore the squares should be 10 over 3 centimeters by 10 over 3 centimeters. Any questions about this example? Any questions, thoughts, or concerns about this example? Okay, so everyone's pretty confident with these? All right. So we're going to move to our last example for our optimization. I'm going to start it off, and then you guys are going to solve the rest. So I have a pop can in the shape of a cylinder. It's to have a capacity of 250 centimeters cubed. If the diameter of the can must be no less than 4 centimeters and no greater than 8 centimeters, I want to find the dimensions of the pop can that will use the least amount of material. So who remembers the volume of a cylinder? How would we find that? Does anybody remember the volume of a cylinder? So this would be our height, and this would be our radius. So who remembers the volume of a cylinder? See, this back to like grade 9 math. Yep, so its volume is equal to pi r squared h. So you know my volume is 250. So we can isolate for h, and we get h is equal to 250 divided by pi r squared. Now, because we're talking about the dimensions of the pop can that will use the least amount of material, what other formula do we need to use? When I talk about how much material I need, what measurements are we looking at? Surface area. So if you guys don't remember, the surface area is equal to 2 pi r squared, because we have two circles, plus 2 pi r h. So we know that we can have our surface area in terms of r, which is equal to 2 pi r squared plus 2 times pi r times 250 over pi r squared. And we can simplify this even more. And that's equal to 2 pi r squared plus, my pi's cancel out, 500 times r to the negative 1. So now what I want you guys to do is I want you to find my domain. So remember, our diameter has to be less than or equal to 8, but greater than or equal to 4. And so you're going to find my domain, and you're also going to find me the radius at where it produces the least amount of material. So I'm going to give you guys 5 to 10 minutes to try to figure this question out.